Hello everyone, this is Shubham Saudari and I welcome you again in the 29th video of our YouTube channel. Today is 29th of January and we are discussing this LeetCode easy problem number 232, implement queue using stacks. So here we need to implement a first in first out queue using only two stacks. The implemented queue should be supported by all the functions of a normal queue, that are push, peek, pop and empty, and while implementing the MyQueue class, so in the void push function which pushes element x to the back of the queue, in the int pop function it removes the element from the front of the queue and returns it. In the peek function it returns the element at the front of the queue, and in the boolean empty function which returns the true if the queue is empty or false otherwise. And we need to note here we must use only standard operations of a stack, which means only push to pop, then peek pop from top, then size and is empty functions of stack operations are valid, and depending on this okay. So here we need to implement a queue using only stack and the stack operations, standard stack operations, that are pop, push, top. So in the first example, my queue will be initiated, then push this first element in the queue, so it will return null, and the first push 2 in the queue, then pick means the first element of the queue, and it will return the output as 1 because the peak element will be 1, because 1 goes first in the queue, then pop, so first will be popped out, sorry, and the empty function will return false because we have 2 in the queue, my queue. So here basically queue data structure is of first in first out approach. So the element which goes first will remove first. So we are pushing 1 here, so we will push 1, so after that we will push 2, so we will push add back, and we will pop that front. This is the queue data structure. We need to use two stacks to implement this queue data structure. So let's see the approach here. And one thing, this operation should have the time complexity as amortized big O of one time complexity, which means performing an operation will take overall big O of n time, even if one of those operations may take longer. So we need to have amortized big O of one time complexity here. So the approach will be, we will use two stacks for implementation. So for push operation we will do these things. We are taking two stacks, so in the first stack 1 and stack 2, so we will remove every element from stack 1 and add to stack 2. These operations will be for push operation, so we will remove every element from stack 1 and add to stack 2. Then we will add this current element in the stack 1 and then remove every element from stack 2 and add to stack 1. So this approach we will follow for push operation. And for the pop operation we will simply pop element from stack 1 and return, so that element will be the first element of the queue. And for peak operation we will return top of stack 1, and for empty operation we will return stack 1 dot empty. So here let's discuss first example. If there are stack 1 and stack 2, the two operations, so first of all we will push 1, suppose in the stack 1. For that we will remove every element from stack 1 and insert in the stack 2. After that we will insert one here. Here the stack 1 is empty, so we will insert 1. Then we will remove every element from stack 2 and insert in stack 1. So here stack 2 is empty, so we will go proceed further. The next push operation, so we are pushing 2. For pushing 2, we will remove every element from stack 1. So here we will remove 1 from stack 1 and insert in stack 2. So we will insert 1 here, then we will push stack 1 this 2, and we will remove this stack 2 from, so then we will empty this stack 2 and add it to the stack 1. So here we will add here. After that, if we need to again push something like push 3, so we will remove every element from stack 1 and add it to stack 2. For that, we will remove from top. So from top we will remove 1, then we will add it here, and after that we will remove 2 and add it to here. So after that we will insert 3 here in the stack 1, and then we will remove again from stack 2 and insert every element in the stack 1. So we will remove stack 2. So for that we will use top function. So we will remove the top element of stack 2 and add it here, then 1, and we will add it here. So this will be our final stack after the push operation. So in this case, if we need, if there is a pop operation for queue, so we will return the top function. As we are pushing the our first element we have pushed, that is 1, so in the queue we will get the top of element, which will be equal to the top of stack. And if the peak operation is there, for that we will simply return the stack 1 of top, so it is the first element in the queue. And for empty, we will just check the stack is empty or not, stack 1 is empty or not. So let's code for this. Before that, if you are new to the channel, hit the like button and subscribe for more content. So we will initialize two stacks here, stack int first and second. Now in the push operation, we will first remove all the elements from stack 1 and insert it to the stack 2. So for that we will use while first dot empty, while it is not empty, and this operation is a standard operation of for stack. So while first is not empty, we will remove every element and add it to the second stack. So second dot push the first element top, first dot top, first dot top, and then we will remove the first element. Here we are inserting the top element of first in the second stack, and then we are popping it out from first, and this while loop will remove every element from stack 1 and add it to the stack 2. Now we will add this add this x in the first, so first dot push x, and then again we will remove every element from stack 2 and add it to the stack 1. So while second empty, second is not empty, so we will push in the first, for first dot push second top element, and we will remove that element using second dot pop, and this will make sure that the queue is implemented successful for push operation. And for pop operation, we will simply take a number from first, So first dot top, then we will pop it out, first dot pop, and we will return this num. So we need to return the popped element, so we are using this top operator for storing that number, and we will return that element, and before that we will remove that element from the stack. In the pick operation, we will simply return first dot top, as we don't want to remove that element. So simply we are returning first dot top, and in the bool empty function, we will just return first dot empty. If first dot empty, then we will return true. If else, we will return false. So let's check for the solution. Yeah, the code ran successfully for push operation, pick, pop, and empty operations. So let's look at the hidden test cases. Yeah, the code ran successfully. Here, to talking about time complexity, we are using this push function, and we are using two while loops. So our time complexity here will be big O of n, where n is the number of elements present in the stack, and for pop we don't need any. It These are the constant operations, and for this these are the constant operations. So only push function will take big O of n time complexity. So that's it. If you enjoyed the video or found it helpful, don't forget to hit the like button and subscribe for more content. And stay tuned for upcoming LeetCode problem of the day videos and exciting monstack web development projects. Let's happy coding, and let's make this year a fantastic one together. Thank you.